Hi, welcome back. This is Professor Rich, and today's lesson on section 6.3, matrices and systems of equations. A matrix is a rectangular array of numbers, or you could say arrangement too. So a rectangular array of numbers. Let me give you an example. Okay, so we use these brackets to signify the matrices. And then just an arrangement of numbers. So this is a 2 by 3 matrix. So the 2 by 3 part is the order or dimension of it. Okay, so again, the order or dimension of a matrix is the number of rows by the number of columns. Now you got to remember, rows, they go side by side, or side to side. That's row 1. Row 2. It's 4, -8, 7. Columns are vertical. So this is column. So I think like column of a building. Alright, we go up and down. So the columns are vertical. Column 3. So it's a 2 by 3 matrix because you always talk about the number of rows by the number of columns. The numbers contained in a matrix are called entries, or sometimes we call them elements. So either one of those. So 3 is an entry of the matrix, 2 is an entry, -5 is an entry, so on. Now a square matrix, you may hear me say that once in a while, is just a matrix with the same number of rows and columns. Okay, you can represent a system of equations with an augmented matrix. So let's look at an example. If I had 3x plus 2y equals 8 and 4x minus 3y equals 5, that's the same thing as the matrix 3, 2, 8, 4, -3, 5. And then the idea is, it's called an augmented matrix because we're putting together two different matrices. Oh, and by the way, I didn't say matrix. Matrix is singular for a rectangular array of numbers, and matrices is just the plural form of matrix. Okay, so the 3, 2, 4, -3 comes from the coefficients of the system. So this is the coefficient matrix. And then the 8, 5 are the constants. So that's called the constant matrix, because there's no variables in there. Or those numbers don't represent variables. Okay, so and then we augment it together. We put it as one matrix. So the thing to remember are rows of matrices are equations. Equations are rows. And we're going to talk about row operations in a little bit. Okay, so let's look at this system of equations. We got two equations, 3x plus 2y equals 8 and 4x minus 3y equals 5. So if I asked you to eliminate x from equation 1 and 2, what would the LCM be for 3x and 4x? And hopefully you're saying 12x. So to get 12x, we need to take equation 1 and multiply by 4. So we get 12x plus 8y. Remember, you multiply through the whole equation. Equals 32. And then we want to eliminate x, so we need equation 2 to have -12x. So we need to multiply by -3. So we get -12x, positive 9y, equals -15. Combine those. And we get 17y equals, what's that, 17. Okay, so that's equation 3. Now from there, we're going to solve this equation. Oh, and notice, 12x minus 12x is actually 0x. You know, I didn't write that because you don't need to, but anyway, so now I'm going to solve it for y. So divide by 17, and you get y equals 1. And then we're going to plug that back into equation 1. So we get 3x plus 2y equals 8. 3x plus 2, because I plugged in 2 times 1 is 2. And I'm not going to show all the work here. Subtract 2, that's 6. Divide by 3, you get 2. Now, the reason I showed you this is let's connect it to matrices. So the idea then is I can just write down the matrix for this system. Remember, rows are equations. So what I'm going to do is my first step is I want to eliminate x, let's say. So I'm going to take this technique here, 4 times 1, and the way I'm going to use my notations, I'm going to go 4 times row 1 plus negative 3 times row 2. And then I'm going to write the result in place of row 2. And the result of that, 4 times row 1 plus negative 3 times row 2, is the exact work here. So it's kind of like bookkeeping. And I'm going to put in 0x plus 17y equals 17. So I'm just going to write the result down of doing these row operations, which we'll talk about in a second. I'm just giving you an idea of what's happening here. We're going to leave equation 1 alone, or row 1. Now my next step is I'm going to take the new equation 2, which is row 2, the new row 2, and I want to solve it for y, so I'm going to divide by 17. So dividing by 17, same thing as multiplying by 1/17. So I'm going to take row 2 and replace it with 1/17 of the old row 2. So that's going to be 0. 17 divided by 17 is 1. 17 divided by 17 is 1. And that becomes my new row 2. Okay, and then I want to now get a 0 where the 2 is. And so the way I'm going to get a 0 there is I'm going to multiply negative 2 times row 2 and add it to row 1. Okay, so if I were to show the work, you would see you would take 3 plus 0, which is 3, and then negative 2 times everything in row 2. Here, let me write it here. No. Negative 2 row 2 is going to be 0, negative 2, negative 2. And row 1 is 3, 2, 8, and I'm going to add them together. That's going to be 3, 0, 6. And that's going to go and replace row 1. So 3, 0, 6. And we'll leave row 2 alone, 0, 1, 1. And then from there, I want to solve for x, so I want to get this 3 all by it. I want it to be 1x, not 3x. So I'm going to take 1/3 row 1, and it becomes 3 divided by 3 is 1, 0 divided by 3 is 0, 6 divided by 3 is 2, and then row 2 we're going to leave alone. And there we go. And then I can read off here that row 1 is 1x plus 1x plus 0y equals 2, so that's just x equals 2. And then row 2 is 0x plus 1y equals 1, so that's just y equals 1. So my solution is x is 2, y is 1. And you can see, you can read it off right here, because again, row 1 is x plus 0y equals 2, so x equals 2. And row 2 is 0x plus 1y, so that's just y equals 1. So you can think of this straight bar here as like an equal sign. Alright, so that's for our augmented matrices. Okay, so that's the technique we're going to be using. And basically, the rules of the game here are what we call row operations. And remember, rows are equations. So anything that you can do by solving using the elimination method, you can do to rows. And so basically what we can do, now this one we don't really think about too often, but you can do it, is if I wrote equation 1 as equation 2 and equation 2 as equation 1, it wouldn't change the outcome. It doesn't change the system. So you can switch any two rows or interchange any two rows. The next one is kind of what we did in the last step. We did it a couple times. You can replace any row with a non-zero multiple of that row. So for instance, in the last matrix here, I took the row 1 and multiplied it by 1 divided by 3, 1/3. Right? So you can multiply, and technically you can divide too, as long as it's not 0. Okay, so we can take any row and multiply it by any number we want, and then by extension that you can divide. And the third thing, you can replace any row with the sum of that row and a multiple of another row. And notice I put in parentheses or a multiple of the row. So basically that was the step I did up here. I took -2 times row 2 and added to row 1, and I replaced row 1 with the result of it. Okay, so that's the row operations. And your goal is to get where you can just read off the answers in that last column there. Okay, so let me get the following. So I'm going to do it for a 2 by 2. 2 by 2, so that's 2 equations, 2 variables. That's what I mean by 2 by 2. You want to get 1, 0, 0, 1, and then the numbers that are going to be in the last column will be whatever x is and whatever y is, because remember, row 1 is 1x plus 0y equals whatever x is going to be. Okay, and then row 2 would be 0x plus 1y equals whatever y is going to be. And then for a 3 by 3, I think it's easier just for me to show you this instead of try to. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. And again, notice the first equation would be 1x plus 0y plus 0z, so that's just x equals whatever x is. And then the second row would be y equals whatever y is. And the third row would be z equals whatever z is. Okay, and then for a 4 by 4, the idea, same idea. Now notice, you're going to have 1, and I like to think of these in columns too. And then 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and then this will be W, X, Y, Z. Okay, and then again, the idea basically, you can continue this, is you get ones down what we call the main diagonal. So in the 1 1 spot, 2 2 spot, 3 3, 4 4, 5 5, so on, and then you get zeros everywhere else. And then the augmented matrix part will be your solution, w, x, y, z, you know, whatever, however many variables you have. Okay, let's try an example. Solve x minus 4y equals 9 and 2x plus 5y equals 5. Now I already wrote the augmented matrix that goes with that. So we got 1x minus 4y equals 9. And then row 2 is 2, 5, 5, because 2x plus 5y equals 5. Now the idea here is as long as you don't break any of the rules in the row operations, you're fine. And then you try to get to the goal where we're going to get 1, 0. This is our goal. Get 1, 0, 0, 1, and then figure out what x and y are. Okay? And usually the process, okay, now again, you can do it whatever order you want as long as you don't break any of those. But there's it's called the Gaussian method, and then there's the Gaussian-Jordan method, which I'll show you. And the idea is you want to get the 1, you want to get a 1 in the first spot, first column, first row, first column. And then and the idea is we work in columns, and I'll show you in a second here. So we want to get a 1 in that first spot. Okay, that's done, so there's nothing to do there. And then our next thing is once you get the 1 in the first column, you want to get zeros everywhere else in the column. So where that 2 is, we want to eliminate that. We want to get a 0 where the 2 is. This is what we want, a 0. So our goal then is, what do we have to do to row 1 and add it to row 2 to get a 0 there? So it's the same question as in the elimination method. How would I eliminate x? And hopefully you would say, well, take 2 times the first equation, which is row 1, and add it to row 2. Okay? So if it's possible for you to do this without, showing the work, then it's fine. But no one says that you can't go, okay, 2 times row 1. That's going to be negative 2 times row 1 is negative 2, positive 8, negative 18. Row 2 is 2, 5, 5. You add them together, you get 0, 13, negative 13. We're leaving row 1 alone. 1, negative 4, 9. Now, once you've done with the column, you move to the next column. So we just finished column 1. We go to column 2, and our next goal is to get the 1 in this. We're in second column, so second spot. So we want a 1 there. And so what we're going to do is we're going to take row 2 and times it by negative or positive 1/13, and replace row 2 with the result of that. So you're going to divide everything by 13 in row 2. Okay, so that's dividing. And then, once you've got the 1 in the spot, you want to get zeros in the column. So I'm looking at the negative 4, I want a 0 there. So I'm going to take positive 4, row 2, and add it to row 1. So that's going to be, again, this is scratch work right here. Scratch. So if I go 4 times row 2, which is, and with my notation it always refers to the matrix that's immediately before it. So 4 times row 2 would be 0, 4, negative 4, and then row 1 is 1, negative 4, 9, which would get me 1, 0, 5, and that's I'm going to replace row 1 with the result, 1, 0, 5. And row 2, we leave it alone. And now you can see we have x equals 5, x equals 5, and y equals -1. So my solution is 5, -1. So that's how you do it. And again, the idea is you want to, it's kind of just a bookkeeping method. Okay? You're just going to write down the result of what you would do in the elimination method. Okay, so this is, get in this habit of writing down what you're doing, and then that way if you make a mistake, you can go back and check and see, okay, where did I get that? How do I do it? And then the other thing too is you can just punch it in your calculator and you don't have to write all the scratch work down that I just wrote. All right, let's try another one. Okay, so let's write the augmented matrix. I'm going to solve this. So we're going to have 2, -3, 2 equals 2. Equation 2 is 1x plus 4y minus 1z equals 9. Equation 3 is -3x plus 1y minus 5z equals 5. Now, again, the idea is you want to work in columns, and you want to start with the first column and get a 1 in the first spot. So first column, first row, first column, get a 1 there. And you can use any one of the 3 rules. And see, I have this 1 here. So if I can just switch row 1 with row 2, I get a 1 in the first spot, first column. Okay, that looks like the easiest thing for me to do. The other option I could do is I can divide row 1 by 2, and I'd get a 1 there. But let's just interchange row 1 with row 2. Okay, so you can see I interchanged row 1 and 2. That's my notation when I interchange. And remember, my notation, the way I do things, it's the notation I wrote on the side refers to what I did to the previous, the one that's preceding it, immediately preceding it, to get this matrix. So I interchanged row 1 with row 2. That's what I did. And again, I want to emphasize, I'm going to work in columns. You start with the first column and get a 1 in the first spot. That was my goal. Okay. Now you want to get zeros everywhere else in the column you're working with. Now get zeros everywhere else in that column. And right now we're working column 1. So I want to get, okay, I got the 1 there, I want to get these 2 zeros. So the purpose of getting the 1 there, because now it's easy to get a 0, so for me to get a 0 in the second row, I'm going to take whatever, in the second row I got this 2. So I take the opposite sign, which is -2, times row 1, where I just got the 1, and I'm going to add it to row 2. Now I'm not going to show the work, I'm just going to do it on the fly. -2 times 1, so I'm just going to go and look at each item. -2 times 1 plus 2 is 0. -2 times 4 is -8, plus -3 is -11. Oh, I'm leaving row 1 alone, so let me write that down. So I just worked to get that 1. Now I want to get the 2 zeros. Okay, now I'm on the third spot. So again, I look. That's why I write this down too. I can get lost and what am I doing? This is what I'm doing. -2 times row 1. So -2 times -1 is 2 plus the 2, and I get 4. And then -2 times the 9. So I go to the next spot, next column. -2 times 9 is -18 plus the 2, and that's -16. Okay, so now row 2 is done. And I got the 0 where I wanted. Now I'll get the other 0. Okay, looking at the, here I got -3. So I'm going to take the opposite of that, which is +3 times row 1, and add it to row 3, and replace row 3 with the result. So you can do it on scratch paper, right? So if you take negative or positive 3 times 1, 4, negative 1, and 9, and add to it row 3, which is negative 3, 1, negative 5, 5, and then write down the result. Okay, so the result is, okay, I'll do it again. So 3 times 1 is 3, plus negative 3 is 0. 3 times 4 is 12, plus 1 is 13. 3 times negative 1 plus negative 5 is negative 8. 3 times 9 is 27, plus 5 is 32. Okay, now column 1's done. I got the 1, 0, 0. Now I'm going to move to the second column and get a 1 in the second spot. Okay, so at this, and then one more rule, just let me add, it's not really, well, it's a good strategy to follow. Whenever you want to get your 1, you can only use that row that you're on. So we're working second column, second spot. You can only use the second row and below. We don't want to use the first row to get the 1, because then we will lose the zeros that we just worked hard to get. So I need to get a 1 right here using only row 2 or row 3 or a combination of row 2 and 3. Okay, and the easiest thing to do, but it causes fractions sometimes, is you multiply by the reciprocal, which would be negative 1/11th, row 2. And I'm going to replace row 2 with that. So 0 times 1/11th is 0. 4 times negative 1/11th is negative 4/11ths. And negative 16 times 1/11th, negative 1/11th, is positive 16/11ths. Okay, we're going to leave row 3 alone. Okay, so now we got the 1. Now we need to get zeros everywhere else in the column, in column 2. Okay, so we want to get a 0 here. So again, the reason you get the 1 is to get rid of the 4, I do the opposite, negative 4 times the row that the 1's in, row 2, plus the row that we're replacing, plus row 1. Okay, so I'm going to go 0 from row 2 times negative 4, 0 plus the 1 gives me 1. And then I'm going to go to the second column. Negative 4 times row 2 is negative 4, plus 4 is the 0. That was the whole point. And then negative 4 times negative 4/11ths plus 1. And then you punch that. You can just punch that in your calculator. You can do it in scratch work. So that would be negative 4. That would be positive 16 plus or minus 11/11ths. So that would be 5/11ths. Okay, and then positive negative 4 times 16/11ths, 64/11ths, negative 64/11ths, plus 9, which is 99/11ths, so that's 35/11ths. Okay, now, so that's row 1's done. We got the 0 where we wanted, and we want a 0 in row 3. So again, the reason of getting 1 is it makes it easy to get the zeros. So I'm going to go negative 13, pick the opposite of the 13, times row 2, that's where the 1 is, and add it to row 3. And then write the result down. So I'm going to get 0, 0, negative 13 times negative 8. Oh, wait. Negative 13 times negative 4/11ths would be 52/11ths, plus negative 8, which is negative 88, 52, and that would be negative 36/11ths. And then negative 13 times 16/11ths, plus 32. Okay, I got to do that one on my calculator. Hang on. Alright, so I get 144/11. Alright, so now column 2 is done. So now we need to get a 1 in the third column. So now we're going to move to the third column. And I'll move to the third. And again, the only thing that I'm allowed to do is use row 3 or below to get the 1. So when you get the 1, you only want to use that row and below. Okay, so we're going to take and just multiply by the reciprocal. So it'll be negative 1136 row 3. So we get 0, 0, 1, and then 36, 44 goes what? 4 times? And the 11s cancel, so that's just 4 negative times the positive. It's negative 4. And we're going to leave the other 2 rows alone. So just copy them down. 0, 5/11, 35/11. Now you're going to get zeros everywhere else in that column. Okay, and again, the reason we work so hard to get the 1 is because to make this one a 0, you just take the opposite of negative 4/11, so that's 4/11, row 3, and add it to row 2. And then let's go ahead and do it. So 0 plus 0 is 0, 0 plus 1 is 1, 4/11 plus negative 4/11 is 0, and then negative 16/11 plus 16/11 is 0. So that row's done. Now let's do row 1, and that's going to be, see, row 1 is 5/11, so you're going to go negative 5/11, row 3. Here, let me just show you what I'm doing. So that's going to be 0, 0, negative 5/11, 20/11, and then I'm going to add it to row 1, which is 1, 0, 5/11, and then 35/11, which is going to be 1, 0, 0, and then that's 55/11, which is just 5. I'm going to put the result for row 1. 1, 0, 0, 5. And you can see x equals 5, x equals 5, y equals 0, 4 equals, z equals 4. Okay, so that's the solution to my system. Alright, and that's using the Gaussian-Jordan method. Let's try another one. So let's, row 1 is 1, 1, negative 3, 4. Row 2 is 4, 5, 1, 1. Row 3 is 2, 2, 3, 7, negative 7. Okay, so we want the 1 in the first spot. That's done. Now we want zeros everywhere else. So we're going to leave row 1 alone. Okay, so I'm going to go negative 4 row 1 plus row 2. So that's going to be negative 4 plus 4 is 0. Negative 4 plus 5 is 1. 12 plus 1 is 13. Negative 16 plus 1 is 17. And we want a 0 on the third row. So that's going to get us negative 2 row 1 plus row 3. So that'll be 0. Negative 2 plus 3 is 1. 6 plus 7 is 13. Negative 8 plus, let's see, negative 8 plus negative 7 is negative 15. Is negative 8, let's see, negative 15. Oh, I'm looking at row, look at this one, let's do that again. I just noticed a mistake. If I did negative 4 times row 1, that's going to give me negative 4, 12, negative 16, not positive 16. And then row 2 was 4, 5, 1, 1, which is going to give me 0, 1, 13, negative 15. So this should be negative 15. And notice row 2 and row 3 are the same, so what that tells you is there's some dependence going on in here. We're going to get an infinite number of solutions. So if I took, if I try to get a 0, okay, so I want the 1, and let's just forget that for a moment and just go through that process. We want a 1 in that second spot, which is already there. So that step's done. Alright, so now we want to get zeros everywhere else in the second column. So if I go negative 1 row 2 plus row 1, you're going to get 0 or 1, 0. Negative 13 minus 3 is negative 16. 15 plus 4 is 19. Row 2 we're leaving alone. And then row 3, we want to get a 0 there, so we're going to go negative 1 row 2 plus row 3. And since they're the same, you're going to get 0, 0, 0, 0. And now, to get a 1 in the third row, third spot, we can't do it because we got that row of zeros. So at this point, this is what's called reduced row echelon form, where the first non-zero number in a row is a 1, and then you go to the next row and you move over 1, right? I explained that horribly. You can look it up. But anyway, it's not that important right now. So anyway, this is what's called reduced row echelon form. And you have this row of zeros, so again that tells us there's some dependence going on, and there's an infinite number of solution. And we're going to do just like we did with the equations now, where we're going to say, okay, let Z be your freebie. And it's a lot easier to do it with this. So whenever you get a row of zeros, if you had to pick, you always move it to the bottom. And then you just, you know, you're not going to be able to get the 1 in that spot for that row. So now we just have two linearly independent equations. And don't worry too much about all this terminology. Just know that, okay, you can't continue from here. And what you do is you're going to let Z be a free variable, just like we did before. And we're going to solve for x and y in terms of z. And it makes it really easy in matrices through going through that process, because look, row 1 says 1x plus or minus 16z equals 19, so x equals 19 plus 16z. And then row 2, y plus 13z equals negative 15, so y equals negative 15 minus 13z, because you just subtract the 13z to the other side. So now we got x is 19 plus 16z, y is negative 15 minus 13z, and z's are free one. It can be whatever we want it to be, where z is any real number. Okay, so that's why I call it free one. No restrictions for z. But once you know what z is, x and y are determined by your choice of z. and that's an infinite number of points, it will make a line, right? This is going to be a line in 3 space. Alright, and then the other special case, remember if you have no solution, and the way that's going to look is if you get an equation with the row of zeros in this side, but you have a number here. That'd be like 0 equals 5, which is false. Okay, so at this point, this is false. Okay, 0 equals 5 is not true, so you just say no solution. So if you ever get a row of zeros for the coefficient equals a number, then you can stop and say no solution, and you go to the next problem. Okay? So just note that. So if you have a whole row of zeros, 0 equals 0, that's going to get an infinite number of solutions. Move it to the bottom, and you're going to have that free variable. If you had 2 rows of zeros, you would have 2 free variables. So every row of zeros is a free variable, basically. Alright, so that concludes the lesson for 6.3. Go to My Math Lab, do your exercises there, and I'll see you next time.